Hi, welcome everybody. Welcome to another workshop of the Internet Computer BUIDL Bitcoin Hackathon. Today's workshop is once again held by one of our education partners. This time we're talking about AstroX, and we'll be joined or we are joined by Michael from AstroX. Some of you might know him as Ghostcorn, and he will be talking about building a multi-sig Bitcoin wallet on the Internet Computer Network. Before we start, I just want to make once more, I want to remind you that if you haven't yet registered for Hackathon, please do. This way you'll get all the latest updates on the Hackathon, on the workshops, and the bounties, and what's going on. I'm pasting the link to our website, Hackathon website, in the chat, and you'll see a form at the bottom. So yeah, feel free to register and feel free to pop any questions. The total runtime of the workshop should be around 30 to 35 minutes, and after that there'll be a short Q&A session. That's pretty much it from me, and Michael, feel free to pop it off whenever you're ready.
Hey, hello everyone. Very happy and honored to join this workshop. And today I'm going to talk about build a multi-sig wallet of Bitcoin on IC. So let me head to the share my screen and head to the topic. So the topic is how to build a multi-sig wallet on IC. So basically we are talking about multi-sig Bitcoin wallet. So first thing is that I'm going to talk about what is multi-sig of Bitcoin. So multi-sig has a long history, a very complex and difficult technique for transact in multi-parties. You can see this graph. So basically, three users on the left, and each one will has its own key and pass some algorithm and collect some signature and control a wallet. And then the transaction will be broadcast to the Bitcoin mainnet, and the recipient will receive a certain amount of Bitcoin. So there is a threshold here. We see 2/3, meaning that two persons approve the transaction, and the transaction will maybe going. So this is very complex. If you look at the Bitcoin script, and if you're familiar with Bitcoin technique, there's a couple components that are using in the multi-sig flow. On the right is the PSBT flow currently using on the Bitcoin multi-sig Bitcoin transaction. On the left is several components are currently using on Bitcoin multi-sig. First is descriptor. What is descriptor? Is describing the wallets and assigning parties using a certain script, saying which the public key will join the transaction and how is the public key is constructed. For example, a BIP44 standard describing the public key and which parties are joining. For example, we have key 2 and key 3 in the multi-sig wallet. And also we describe all the keys, and we also need miniscript. Miniscript is a spending policy describing using the script. So here we have a complex script saying in which key and passing how many blocks, and will be transact using another key. So there is two keys transaction and with a time lock on the block number. So using miniscript, you can describe the spending policy. And the last part is the PSBT. So PSBT is partially signing Bitcoin transaction. When the transaction happens, you need a data structure that describes which parties will be signing on the Bitcoin's inputs and or how the outputs are constructed. On the right is the BSPT transaction flow. That here we have three parties signing a PSBT: Alice, Bob, and Carol. When the PSBT is distributed, and Alice will run a funnel and create a PSBT for all parties. And then each party will sign with his own wallet and collected by Alice. And Alice will combine the PSBT, and all inputs will have 3 signatures. And then Alice will finalize PSBT and broadcast the transaction and pay the gas fee. So Bitcoin multi-sig is pretty complex if you're combining different components and use complex flow, and you have to synchronize all the signing parties, synchronize all signatures, and calculating each inputs and outputs, make sure everything goes fine, and then go through the broadcast, go through the mainnet, and it causes a lot of trouble if you don't synchronize and you don't do it correctly, and the logic would be very, very hard to extend it. Even we have manuscript right now, yet you cannot, easily extend how many parties and how the policy will be made. So everything will be prescript in the wallet or prescript before the transaction happens. So this is too complex for building a multi-sig of Bitcoin. But right now, we often seen we use other components to sign a multi-sig. For example, on the left, maybe one person will initiate the transaction, and the other person will be the co-signer, and also have a backup wallet on the left. And only the initiator and the co-signer approve the transaction, and the transaction will go through. When a transaction you have to be declined, so you use maybe using a backup wallet to decline the transaction. That's the normal usage of Bitcoin multi-sig wallet right now. And what's different when we are thinking about the same architect when we are thinking building a multi-sig wallet built on IC? So what's benefits when we are building multi-sig wallet on IC? The first one is that we are using Canister smart contract as the wallet. This wallet will be controlled by users' identities, not users' wallets. When you're looking back this graph, on this graph, Bitcoin users always use their wallet to approve the transaction. But on IC, we only use users' identity. Wallets is a smart contract when it's on chain. So basically, you have different parties using different identities to log in to a wallet and sign the transaction. And business logic are programmable. For example, you can code spending policies, or you can code how many people with different roles, and we have different spending limits, and which people will have the power to initiate the transaction, and which people will have the power to authorize the transaction. You can compose and you can customize all the business logic because you are using the Canister smart contract, not just like mini script or just simple Bitcoin script. And then using Canister smart contract, you can use TECSA. What is TECSA? T means the threshold. The threshold signing scheme is provided by the IC subnet. For that, you don't worry about the keys, the security. On traditional Bitcoin signing, you always worry about the key security because each parties will have to securely, manage their own keys, and all keys should be managed securely by the co-signing scheme. On IC, you don't have to worry about the keys. Each one log in with the identities and use the threshold signing. There's no keys within, and the signing part will be managed by the IC subnet and IC's security model. The fourth is that all components can be extensible and composable when you are building blocks in the ecosystem. For example, you can code business logic using JavaScript as SDK. You can log in with the like internet identity. You can use our infrastructure to manage all the canisters and create and delete the canisters and manage as you will. So all the components can be extensible and composable. Now, because we are using Canister smart contract wallet, now the models will have to be changed. For example, like I said before, user can use login using their own identity, not just wallet. So here we define user 1, user 2, user 3 as own identity. And there's no wallet when user approves the transaction. The transaction will be proved by the approve function. So this is only the function call, it's not a script call. So user 1 will approve the transaction ID. User 2 also approve the same transaction ID. User 3 might reject the transaction ID. And all the function call will be managed at the threshold inside the multi-sig Canister wallet with a certain amount with recipient and with the transaction ID. The wallet will be managed by a single multi-sig Canister wallet canister. And this canister will use the threshold signing to broadcast the transaction. And use this part, we can use the Canister smart contract wallet to do the same functionality as the Bitcoin transaction using like this complex model. And for that, we can even code up a complex architect. Like we can define the providers. Like I said, providers can be multiple groups, like a company or a studio or a certain amount of people. We can provide a group of people to manage all the controllers and wallets. So providers will be managing the registry for all the controllers and wallets. And the controller will be managing who is logged into the system. So we can define 3 people, 4 people, or 5 people to manage their own wallets. We can define the groups. We can also manage which wallet we want to create, like a company wallet or a group wallet or a family wallet. You can create as many wallets as you want. And you put all the people into the wallet so that only these people can manage this wallet, and you can add or remove people as you like. Also, you will be able to manage the action and threshold. So threshold defining how many people approve the transaction, and the transaction will be going through. And for example, 3/5, that's 5, only 3, after more than 3 people approve the transaction can go through. The action meaning that each transaction will be managed by the action. So the action can be delete and remove and create as it will. When it comes to the wallet will be managing the fee, managing the account UTXO, and also the Bitcoin address. The Bitcoin address will be testnet address, will be mainnet address, and with different different type of address, like witness P2WH or normal like one BTC address. And the last part is the TS sender, transaction sender. The transaction sender will be using the threshold signing ECSA to get address and use the Bitcoin API to get the fee and get the UTXO and send out the transaction and broadcast the transaction to the mainnet. Okay, I just described provider and controller and wallet. So let me show you the code. So we have canisters here. Canister, we are using Rust code to construct all the canisters. Here we have 3 different parts. One is the provider. It's a provider which is the multi-sig provider. In this provider, we have several functions. We have controller. We can create as many as possible, as many as controller. We can add controller user. We can remove controller user. This will be working like a registry because when we create different controller meaning different groups of people, and all these people will be managed their own wallets. So the provider would be a like global registry and create all the controller. And we are going to the multi-sig controller. In this controller, we have even more functions. We can create, upgrade, app may. App may means we can create wallets. We can upgrade with the wallet. We can get the wallet's ID. And also we define the user's role, like which is the manager of the wallet, he can also initiate the transaction. We can also remove some of the user from the wallet. And then we can create action, like we can initiate the transaction. We can list all the actions we need, and we can sign the transaction. And we use the controller to manage the user's role and the actions. And the final part is the wallet. The wallet would be pure functional canister. You're using Bitcoin's API. We can set the Bitcoin's network. We can get Bitcoin's key, public key, and get the address. We can get the balance, get the UTXO, get the fee, and see which one is the owner of the wallet. And finally, we can broadcast a transaction. I'm not going through the detail of this code, but just showing the interface that we have, because all this stuff are basically following that graph. So let me demonstrate a little bit about the working demo. So this is the small demo we are building, demonstrate the idea. Now we have 3 canisters. These 3 canisters are controller. We have 3 controller groups. Each groups will contain different group of people. But here I just define the threshold and the group number of people for each group, like 2/3. In this group, in this controller, meaning this group, we can add more people here. We can also set the network of the wallet. And then when a wallet is created, we can get the balance, get the fee. And let me switch to another wallet. There's another group with another wallet. And we have this amount of balance. Okay, let me try to define a transaction. Let me get back to this one. It takes a little time to load the transaction. So here, I copy the address. Let me go through the blockstream. So here I have this amount of Bitcoin matching this amount. So I can, because I'm the owner of this wallet, I can send to a certain address. Let me just copy an address like this one, for example, or just this one. Okay, this one. Okay, say one, two, three, four, five, six, seven, 8. Okay, a little bit more. Okay, I just send 10,000 sats to this address. I can press the OK. When I press the OK, I say the send. However, it's not sending. It's just going through the transaction tab. On this tab, say we'll be waiting for signing. So I have to sign the transaction. And I need because the threshold is 2/3. So basically we need 2 people to sign this transaction. When I sign it, my colleague may also want to sign it. After that, the transaction will be going through. I'm not not going to sign it because there are a couple transactions here. You can see different people signing the transaction with history and transaction we be going through. And this is our actions, and going through will be co-signing by the threshold. So different people will be logging into the system. So remember, I just talked about people who don't have the we don't have to manage the key. So when we log in to the system, I just use my fingerprints to log in without any extension wallets or any other wallet can log in with our identity. So all things will be managed by the IC, and all these things are security by default. And the wallets will be on chain. There's no key to sign, and there's no key to create it. So everything will be on chain and be secure. Now, this is how we build a wallet on IC. Let's go to the summary. First thing, we use on-chain API to create and manage the Canister wallet and use that wallet to manage all the assets. We use IC's BTC API to fetch UTXO and fee. And we write logics inside the Canister to manage complexity, including the role of the user and the threshold and all the other stuff. What is most important, that user won't need to worry about the key, because when they sign in or sign up, they use their own security device. And wallets, this wallet is Canister wallet. A wallet uses threshold signing to sign the signature and broadcast to the network. So this is how we build a multi-sig wallet. You can see the difference between traditional Bitcoin wallet, which is using the script to describe and use the off-chain managed service to collect all the signatures and broadcast the network. However, because IC is a smart contract platform, so everything will be on-chain. Everything can be written in the Canister smart contract wallet, and the logic can be very complex. So yeah, that's how we do the multi-sig Canister, and wish you luck. And yeah, let's build something incredible on the IC and with the Bitcoin. Okay, that's the thing. Yeah, I want to share.
Cool. Thank you, Michael. Amazing. Right on time. 30 minutes on the dot. I guess we can switch over to the short Q&A section now. So, guys, if you have any questions, feel free to pop them in the chat.
Yeah.
I think we actually have one already. Christina is asking, HTTP outcalls on the IC internet computer are still for 400 million, right?
Yes, currently yes. I think it would be cheaper after the optimization, and would be much better. Maybe the coming next year, or maybe coming months or the next year. Yeah.
Okay. Amazing. Yeah, she said thank you. Any other questions, guys? In the meantime, Michael, could you maybe share the GitHub repo of kind of a project?
Oh, sure.
That people could use to practice on?
Yep. Let me type into the here.
Okay. Amazing. Any other questions? We'll give it a minute, guys. In the meanwhile, I have a question. So building a multi-sig wallet, Bitcoin multi-sig wallet on the computer, how does that affect the security of Bitcoin transactions?
Excuse me, I just couldn't hear the last
Yeah,
bit.
how does that affect the security of transactions?
You do mean the security level of the IC?
Yes,
or?
yes.
Okay. Okay. So the threshold signing would be initiated. The first thing first. Threshold signing is important. On the IC, you use the consensus to manage the key constructor. So there's actually no key there before the transaction is happening. So when the threshold is happening, all nodes will be shuffled and use consensus model um, to construct the public key together and go through many rounds. For example, 3 rounds or 8 rounds, depend decided by the IC's consensus model. And all the nodes will be running for certain rounds. And after that, like uh, 1/3 of the nodes and plus one will be going through, and the key will be constructed. And each canister will be getting their own public key, and the signing will be complete. Right now, the Bitcoin subnet will be running on a larger nodes, like 34 nodes, saying 34 nodes will be running all the threshold signing, and 1/3 of the nodes, for example, the 11 plus one, that's 12 nodes, 13 nodes will be using will be the threshold, and after only 30 nodes, only after over the 30 nodes will be the threshold of the key signing, and the transaction will be going through. And that's the security model of the IC's consensus. So there's no key there. There's no single management key there, and all the nodes will be shuffling. And each 5 minutes and each, or I can't remember, each 5 minutes or each 15 minutes will be reconstruct the key, redistribute the key, and the security would be very very high level. And if you're going through the bigger network, and the threshold will be running more rounds and keep the security very high. Yeah, that's the main concept of the threshold signing. And I think it's more important that we can remember two things. One is that the threshold signing will be managed by the nodes, but the nodes will be shuffled and picked by the consensus. That's the key thing. And the second thing is that user won't have to use the wallet to log into the system. So you only have to use your security device, like fingerprints or facial recognition, or provided by the iPhone, and you can log in, and then you don't worry about the private key issue. And 3 of 5 people will be co-sign or co-own the wallet, and minimize the risk and minimize the key loss, the risk. So I think all these parts coming together will be secure your fund and secure all the transactions. Yeah.
Cool. Thank you. Amazing explanation. I guess that also kind of touches upon the question that's just been asked. Artem is asking, what are the advantages of using AstroX versus wallet and password?
Okay. AstroX. AstroX kind of what we are a wallet team, so we are building kind of smart contract wallet for a while. Initially, we are using the same patterns or same design of internet identity, and using identity wallet other than the cipherless wallet, because we are thinking cipherless management is very difficult and very hard on daily use. and especially for non-crypto people and use their crypto wallets is not secure by default. We just use the most secure way. For example, you can use your iPhone security enclave to manage the keys and use the security enclave. People won't be able to lose their keys because security enclave, even Apple cannot extract the private key there. So when you log in with the internet identity or log in with AstroX wallet, you just use a fingerprint using secured by the chip inside your computer, or use your cell phone and log in with your face ID, or use your fingerprint, and that will be really secure for normal daily use. That's one thing. And the second thing is that we are also building a Canister wallet. Canister wallet just use the Canister smart contract to write complex logic. For example, when we are building a Canister wallet for Ethereum, when the Canister wallet is, we will also embed some functionality and modules inside the Canister wallet. For example, auto approve and auto de-approve. Also minimize the risk. When using ERC20, you have to approve all the transaction, and maybe for a while you don't have the time, or you just forget to decline that approval. So you use the smart contract wallet, you can do it automatically and don't worry about the risk. And then you can use the smart contract wallet to call another smart contract, just like the function call you are using on the Ethereum network. And most importantly, we can use Canister smart contract to write smart contract logic to manage Bitcoin's assets. So I think that's the most powerful thing. We can do it. Yes, that's the difference between AstroX wallet and two normal wallets. Yeah.
Amazing. That was a terrific answer. Thank you. Thank you very much.
Thank you.
Unless there are any other questions, which I think there are not, I think we can slowly wrap it up. Guys, thank you once again for coming for this amazing workshop. I hope you found it as interesting and useful as I did. One final reminder that tomorrow there will be no workshops for this hack, but we'll be joined by Bob from Bionic on Friday, who will be holding on a workshop about ordinals. And one final reminder to join the Encode Club Discord server and to join the Internet Computer Dev Community Discord server, where the DFINITY team will be holding or is holding office hours for all the hackers each Wednesday. Thanks once again, Michael, for the workshop, and thanks to everybody else for coming in and listening, and see you tomorrow.
Thank you.
Bye.
Bye-bye, everyone. Bye.